Have you ever wondered how a frisbee flies? We've all seen frat bros throwing around a frisbee in the quads in East Halls. So this is just another way that science of physics and fluid mechanics are all around us. Let's take a look from a fluid dynamics approach to explain this phenomenon. As you can see from the diagram, the fluid, in this case air, passes both above and below the frisbee. From a design standpoint, we can see how the top is somewhat curved, whereas the bottom is straight and hollow. As the fluid passes past the frisbee, the air on top, due to its curvature, moves faster than the air moving in a straight line on the underside of the frisbee. This causes the pressure on the bottom to be larger than the pressure on top, therefore providing lift, keeping the frisbee airborne. Another large aspect of the frisbee motion is the gyroscopic inertia provided by the spinning motion. This is the same principle which keeps a toy top spinning. Without this, the frisbee would simply fall to the ground. If you aren't yet convinced, here's our explanation using material that we learned in class, specifically Bernoulli's equation.
So here you can see our frisbee diagram with the air flowing around it. And you notice the curved surface, which causes the velocity on the top to be greater than the velocity through the bottom. And if we go back to our friend the Bernoulli equation, we're going to assume that the difference between the heights, in this case, are negligible. And then if we solve for the pressure on the bottom, by moving the velocity to the other side, because velocity 2 is greater than velocity 1, this change in velocity term is going to be positive, and thus P1 is P2 plus a positive term. So we can algebraically conclude that P1 is greater than P2. And back to the diagram, if we have a high P1 and a low P2, this pressure differential is what causes the upward lift and allows the frisbee to fly.
This application of Bernoulli's equation can also be used to explain the lift for several things, such as airplane wings. In conclusion, fluid velocity differentials cause pressure differentials between the top and the bottom of the frisbee, therefore providing lift. So the next time you're chilling with your bros in the quad, remember Daniel Bernoulli and his revolutionary equation made this all happen.